Well, hello and welcome to this exercise on uh, Pentagon, congruent triangles, ratios, areas, sine rule. Now, this comes from a past iGCSE exam question. Now, to begin with, what we've got is uh, a regular pentagon inscribed in a circle, right? And it says uh, the vertices A, B, C, D, and E of a regular pentagon lie on the circumference of a circle, center O and radius 7 centimeters. The vertices also lie on the sides of a rectangle WXYZ. Now, the objective of the whole exercise, the final point, is to calculate the ratio of the area of the pentagon ABCDE to the area of rectangle WXYZ in the form 1 to n. Now, if you get all that right, you get 19 marks. Now, before I get to this point, which is the last point in the question, you have to carry out some exercises to get to this point. And the first one says you need to show that the angle DOC, this one here, is 72 degrees. That's what you need to do. Now, to do that, I've done some construction. So I've created another 3 triangles or 4 triangles. So now these triangles are all isosceles triangles because they got sides of 7 centimeters each, because that's the radius of the circle. The third side of the circle will be the sides of the pentagon, and because it's a regular pentagon, all the sides are equal. So in effect, what we've now got is 5 congruent triangles, and the sum of the angles at the point is 360, and there are 5 of these angles there. So if you divide 360 by 5, you end up with 72 degrees, and that's the value of angle DOC. Next, we need to show that this angle here is 108 degrees, this one here. Okay. Now, to do that, we know that the sum of the interior angles of a pentagon is 540, and because we've got 5 of these, if you divide 540 by 5, you get 108. So this angle here is 108 degrees. Okay. Now, next, we need to find this little angle there, this one here. Okay. Now, we need to consider the triangle CBY, which is a right angle triangle. That's 90 degrees there. Now, the angles on a straight line add up to 180. So this angle here will be 180 minus 180 minus 108. So this angle is 72 degrees. Okay, so that's 72 degrees. We need to find the angle CBY. Now, to find the angle CBY, if we then do 180 minus 90 minus 72, I will get 18 degrees. So the angle CBY is 18 degrees. Now, next, we need to find the value of the sides of each side of the pentagon there. Now, before we can do that, we need to find this angle so that we can use the sine rule. Now, because this angle at the center is 72 degrees, so the angles at the bottom, this one and that one, should be 180 minus 72 divided by 2, and we get a value of 54 degrees. So this angle here is 54 degrees. Okay. Now, we need to apply the sine rule here because we got this. We're looking for this side here, and this side DC has got, or CD has got, an angle opposite it. The line DC has also got an angle opposite it, which is 54 degrees. So CD over sine 72 degrees is equal to OC divided by sine 54 degrees, and OC is 7 centimeters. So CD is now 7 times sine 72 divided by sine 54 degrees, and that gives us CD of value of 8.22899. But we are asked to find the length of CD correct to three significant figures. So CD then becomes 8.23 centimeters to 3 SF. That's CD. Okay, now next. Right, now carrying on with this slide, we're supposed to calculate the area of this triangle here, triangle ODC. Because if you can calculate the area of a triangle ODC, then you can go ahead and calculate the area of the whole pentagon, because these five isosceles triangles are congruent. Okay, so it says calculate the area of triangle DOC, and for DOC we know that this radius is 7 centimeters. We also know that this radius is also centimeters there, because the radii are equal, and between them they contain or subtend the angle of 72 degrees there. So what then comes to mind is to do the usual half AB sine C. So the area of this triangle then becomes a half times 7 sine 72 degrees, and that's what you got there. Now a half of 49 is 24.5. 24.5 times sine 72 degrees gives us 23.3 centimeters squared. So the area of this triangle is 23.3 centimeters squared. And therefore, to find the area of the whole pentagon, we then do 23.3 times 5, and that gives us a value of 116.5 centimeters squared, and that is the area of the whole pentagon. Now, next we're supposed to find the area of this sector here, this one here. And the area of this sector will depend on, firstly, the area of the area of the circle, and secondly, the angle subtended in the at the center by the line CD, or the arc CD. So now we then do the area of the circle is pi r squared, or 7 squared pi in this case, and 7 squared is 49, so 49 pi. Okay, so the area of the sector ODC then becomes 72 over 360 times 49 pi. Okay, because this sector has got to be the area of this sector has got to be a proportion of the area of the whole circle, and that proportion depends on the angle subtended at the center by the arc CD. So we now got 30.8 centimeters squared as the area of the sector. Right, now we need to find, in order to find the area of the rectangle, we need to find this height here, xy. And to find the height xy has to be in two sections there. Okay. Now, firstly, we look at the angle XBA, this angle here. Okay. So that's what we got there. And to find this angle, we know that this is 108 degrees, and that's 18. So to find this angle here, we're going to do 180 minus 108 minus 18, and that will give us a value of 54 degrees. Sorry, 54 degrees. So this angle is 54 degrees. Now we need to find XB using cosine, because we know the hypotenuse, which is 8.22899, and we know this angle here. So XB then becomes, so XB over 8.228 is equal to cos 54 degrees. We get that XB will then be 8.228 times cos 54 degrees, and that gives us XB of 4.836 centimeters. Now next we need to find BY. Okay. Now similar thing again. We know this angle is 18 degrees, We know the hypotenuse, which is 8.222899. So in order to find xb, we should do in order to find by, we should do by divided by 8.2889 times the cosine of 18 degrees, and that's what they got there. So by be 8.228 times cos 18 degrees, and then gives a value of 7.825, and that's be the value of by. So now we are now in a position to find the value of the length of xy. Right. So now xy is by plus xy is the sum of by and xb, which means 7.825 plus 4.836, and that gives us a value of 12.661. Okay. We now need to find, in order to find the area of the rectangle, we now need to find the distance zy. Okay. Right. Now, cy, we're trying to find the value of cy here. Now, if you divide cy by the hypotenuse, which is 8.228, and that gives us the sine of sine 18 degrees. So cy is now 2.542 centimeters. And if you look closely, this triangle here, triangle BCY, and triangle EZD are congruent. So cy is equal to ZD. So now the length of ZY then becomes ZD plus DC plus CY. So ZY is now 2.542 times 2, because CY is equal to ZD plus 8.228. So ZY is now 13.313 centimeters. That's the length of ZY. Right. Now, we now have to find the ratio. Now, we know the area of the pentagon at 12.661. We now need to find the area of the rectangle, and the area of the rectangle will be 12.661 times 13.313 centimeters. Okay, right. So, and that gives us a figure of 168.55 centimeters squared. And now for the last section, to find the ratio of the area of the pentagon to the area of the rectangle in the form 1 to n, we then do, if we divide the area of the pentagon by itself, okay, and then divide the area of the rectangle by the area of the pentagon. So we've got 116.5 divided by 116.50, and this will give us 1. If you then divide 168.56 by 116.50, or 50, sorry, that will give us a value of 1.45. So the answer we require is 1 to 1.45. Phew. Now, I hope all that made some sense, and please subscribe. Thank you for watching. Hopefully see you again sometime.